into your remainder. Okay. Now, that's the basic idea. A lot of processors, by the way, will have an instruction that's called a shift or a rotate that allows you to do that. Obviously, we don't have such an instruction here. How can you handle that sort of thing? It's easy to shift left, right? No.
Yeah, sure.
Correct. You can shift left, correct?
Yes.
You just add a number to itself, and that'll shift it to the left one place. I'm trying to figure out a way to give you a big hint on this thing without actually doing it, because it's a relatively simple process, really. Think about it this way. If there's a 1 in this position, you want to put a 1 in this position. Okay, so question number 1 is, how can you find out if there's a 1 in this position?
And it.
Yeah, you use an AND instruction with an appropriate, the term is usually called a mask. If this is my X, and I have a mask that looks like this, if I do an AND between my mask and X, that'll tell me whether or not I put a 1 in bit 0. Okay. Now, if you think about that, that's the real key to the whole thing. Just do it a bit at a time. But you shouldn't need 16 masks. You should be able to do it by working with the 1 mask that you have. Okay, that gets you started, give you an idea where to go with it. One of the real purposes of
It's the same method
working
you did.
at this level is to be able to think in those kinds of terms. You know, how can I get down and just look at those bits and move those around and get them where I want them? You're going to put that AND statement there between the mask and X into a loop where you can check each bit. And then there's a way of accumulating the result into the answer. Okay, and you see, if you think about it, remember one of the conditions on the problem is that you wanted something that is a constant let's see. Try to find an approach that takes a constant amount of time to execute, independent of the actual value that you begin with. Well, if you just go through and check those things a bit at a time, you're going to check all 16 bits, independent of how many of them have 1s and how many of them have 0s. That's a constant amount of time to do it, the job. Okay. I hope that'll get you started in the right direction. Anything else? Okay.